can get 3 over negative 8.
You want to write down what your thought process is? I'm trying to, yeah. Would you mind writing it down?
I
Sure.
think if you put negative 4 here, then this is 0. This is 0.
If you plug in?
Yes,
Oh,
the negative 4.
oh, okay. Yeah,
Then I can get 0 over 0.
okay.
But here, if I put negative 4, then I can get this number.
Mm-hmm.
Why these are different?
Oh, so why do you get a different number when you plug in negative 4 here when you plug it in here?
Yes.
Yeah. Well, when working with our original problem right here, we have to look at our value that makes it undefined. And you were able to find that value, which was negative 4, and it's also 4 too. If we plug in negative 4 and 4 to our denominator, we get 0, okay?
Yeah.
So that is a solution that is not, it's a solution that shows us what the domain of this fraction is. So we'll actually be working with solving rational expressions later. So this is really good. This is kind of a good foreshadowing to what we will be doing in the future, okay?
Okay.
So, but I like how you're thinking like that, okay?
But just if we cannot put negative 4 into x, but I can put negative 4 in simplified one, then I think these two are different, right?
They are different, yes.
In some sense.
In some sense, they are different, yeah.
Different.
Well, when we get to solving rational expressions, you'll be able to see why those two numbers are different. Okay?
Thank you.
Good point, thank you. All right. So our next operation we're going to work with is multiplying. And in the warm-up, I believe, Greg multiplied those two numbers together. So Greg, if you so kindly would like to come up and explain how you multiplied those two numbers together.
Sure.
We can get a sense of what's going on here with multiplying.
So it was 2/3 times 4.
Okay, yeah.
Okay, so I know that when I'm multiplying two fractions, if I have like a over b times c over d, it's just ac over bd.
And so you're multiplying, so is it
So I
safe to say that you're
multiply
multiplying across? Oh, okay, so the
Yeah.
numerators together and denominators, okay, I understand.
Exactly, so this is 2 times 3 over 3 times 4.
Mm-hmm.
And then if I can get a cancel, or I can rewrite this as 2 over 4 times 3 over 3. We know 3 over 3 is 1. So we're left with 2 over 4, which is the same, which is 1.
Good, yeah. You actually said something you could have used a different method. And the other method that you could use is you could actually multiply these two numbers out and get 6 over 12, and then we can just divide by the common factor, which is 6. And we still get that same number, we still get 1/2, okay? So that is the steps that we're using to solving rational numbers, and we're going to apply that to what we know about rational expressions and what you guys saw in the warm-up that we did today. So take about a minute or so, work with yourselves, work with your partner, try to figure out, maybe not an answer, but some components as to where you would start with this problem.
No, sorry, I'm trying this on. Okay, I remember that you multiply out and see, or you try to cancel that stuff.
Well, let's do it the method that you used. You multiply out, so let's just continue with that.
Guys, come up with something over?
Yeah.
What do we got?
That was the one so far. Yeah.
Oh, so you're doing that second method where it's like you multiply find numbers first, and then you're finding the common factor. I
Yes.
like that.
Yes. With you.
Oh, thanks, Max.
Okay, and then we can just,
I can do that.
Well, I'll let you know.
Okay.
I like that.
Thank you.
mhm. Then should we just start canceling our A's, or do you want to pull the ones out?
Yep.
So you're doing a method where we multiply and
Yeah, you were that.
the second?
Yeah.
Okay, I understood.
So I have to change my over for A's for you.
Okay.
Yeah. Oh,
I think Dave's cheating off of.
well, it's true.
We should probably talk to the professor and see if.
Right.
Class.
So Tessa so kindly volunteered to come up and figure out her method of solving this.
Okay, so I just decided to like multiply across, because it was just easier for me to see it, so 4 times 15 is 60. And then I just borrowed the A, 30 squared. And then the bottom is 80. And it's a cube. So for me, I kind of just reduced, like, I looked at this as like 6 over 8, so it's like 3 over 4, like earlier. And then since you have like commonness, so like I get rid of the 1 since there's 3, so I have 2. And then I have that 1 up there. Thanks.
So we used the method of multiplying across and then finding the common factor, and then we used what Dan found in the warm-up, which was dividing by variables with exponents in it, okay? So we used what Dan knew, and we were able to figure out an answer of 3b over 4a. We can also use our other method that Greg used over here, and that's to factor it out first and then cancel. And if we were to do that, we get 2 times 2, I factored out the 4, times a, times I factor out the 15 to get 3 times 5, and I factor out the b, and then my denominator, I have a 5b, or whoops, I'm sorry. There you go. 5 times b, times, I factor out that 16, I get the 4 times a, times a. We can actually factor out that 4 if you want to go 2 times 2, same thing with 4, 2 times 2. Okay? So we have a bunch of variables and numbers here, and then we're able to cancel out. So I see a 2 here, I see a 2 here, get those guys out of there. I see a 2 here, I see a 2 here, let's get that guy out of there. I see a 5 and a 5. I see a B and a B, A and A. So if I see what's left, I have a 3 on the numerator and a B, 3B. In my denominator, I see I got a 2 and a 2 that are multiplied, so it's 4. And I see I have an A and an A, which Dan, again going back to Dan's warm-up, A times A, you can think of that as A to the first turns to A squared. And we see that we get the same result if we do either way, okay? So I'm giving you guys a choice as to which way you want to multiply these out, okay? Let's look at our steps. 2 methods. Our first method, we're factoring the numerator and the denominator across, or multiplying, we're factoring the numerator and the denominator, multiplying across, and then dividing, canceling, or simplifying. And our second method that Tess showed us was you multiply across. We multiplied across, and then we divided and canceled out by the common factor. Okay, so I'm giving you guys 2 methods. You can do it however you'd like. Okay, and that's with multiplying. And we got one more, and that's division. All right, dividing.
Can you go back?
Oh, I'm sorry. Yeah, sure.
Cancel it.
Go right ahead. No, it's fine.
Can you go
Tap
down?
that again. There you go. Dividing.
Okay, I'm good, thank you.
All right, yeah, no problem. All right. So now we're going to focus on the last one before we get to our fun activity today, and it's dividing. So dividing, we found out about rational numbers, Jeremy actually, I think it was Jeremy, let me go back.
Yes,
Is it Jeremy? There we go. Yeah, Jeremy divided those two rational numbers. So Jeremy, so kindly would like to come to the board and explain how you found that answer of 3/7 divided by 14/9, or, I think that was it. Yeah.
9/14.
9/14. Oh, I
Okay,
gave you a
so
little.
we have 3/7 divided by 9/14. That's actually 9. And then so for me, I have to actually see it visually so I remember the steps. So I actually write it out 3/7 over 9/14. And then I'm just looking for a way to multiply by 1 where I can cancel out that denominator. So I will actually do 14/9 over 14/9. That's the way that I can remember
That's
the way.
it.
So that actually, now I got messy here.
The big numbers, yeah.
Yep, so then what did I do?
So is it multiplying the two numbers, or what?
You're good.
I'm good?
Yeah.
Okay.
You got it.
So, yeah, then we multiply, we can work it all the way out, or we can just go right to our canceling out. We know this cancels out. We have 3, we have a 1, that's a 1, that's a 2. So we're gonna go for 2/3.
Okay. So then when you multiplied those, you used the method of just factoring the 2 and then multiplying across. Okay, I understand. Good. Then we get a number of 2/3. This expression right here, this 14/9, how is it? So it's related to 9/14 because it is flipped, right? And what we call that is the reciprocal. I'm gonna write that down, reciprocal. And when dividing, this is really key for us to solve these problems, is to figure out what the reciprocal is. And anytime you divide rational numbers, you are essentially multiplying by the reciprocal. So 3/7 times the reciprocal of 9/4 is just flipped to be 14/9. And then Jeremy was able to figure it out and got our answer of 2/3. We're going to use the same method of the reciprocal over to how we divide rational expressions. You guys got a minute again by yourself or with a partner? See what you can figure out with this one. I'll be circling around if you guys need anything. So from what you know with rational numbers, try to apply it to rational expressions.
Good for you.
We do.
Oh.
Not test, we're trying to test.
She's all
You guys are nasty today.
Get real.
Thank you.
So do you want to multiply through, or do you want to start canceling out? Cancel factors? Let's do that.
Do you want to compare or do you want to not?
No, because I'm right. Wonder why? Because I cheated on Greg and Jim.
You'll be all right. Make sure. Are you be okay to show that method on the board?
Yeah, sure.
Okay, so we got 2.
Okay, so,
I did this movie,
alright, alright, so we are going to see how to solve this problem. Can I move this down a little bit?
There's an answer there.
There's not an answer.
Ah.
You can do your work here if you like. Oh, I like to use the right, good. We're gonna actually talk about that, no problem. After this one, yeah.
You ever seen a five?
Five.
Five?
Oh, I see.
That is a-
So we have 2x, 5. Oh, 5.
Yeah. I see a 5 there, 5 there. Very good.
3, y. So 2x,
Yeah.
3a.
Very good. Awesome. So you did the method then of factoring out, multiplying across, and then canceling out when you multiply those rational expressions. Very good. So our answer comes out to be 2x over 3a squared 1. You could have also done it the other method that, I believe, Greg, you did the other method, right? I think so. And the last one sure did. Yeah, so you could do that method also that Greg did, where you multiplied across and then found the common factors amongst each. But that's very good. But what fractions tend to do is throw a curveball at us, and what it is complex fractions. And Jeremy actually expressed his rational number previously in a complex fraction. So what a complex fraction is a expression where the numerator and denominator contain a rational expression. So in this case, both the numerator and the denominator contain a rational expression. And a way that we can rewrite this is, so we have 4x squared y over 5a cubed b cubed divided by 2xy squared over 5ab cubed. And Jeremy actually did it over there, but I'm going to rewrite it right here. Well, we can rewrite this as just a straight division problem. So we have 4x squared y over 15a cubed b cubed divided by 2xy squared over 5ab cubed. So we can rewrite it as just a simple division problem like that, or we could just do Jeremy's method, which Jeremy's method said that, okay, I need to find a number to make that denominator
1.
1. So complex fractions, don't be scared about them. It's going to be a little curveball thrown at us, but just think of it as just a straight division problem. I'm going to scroll down a little bit. Can I scroll down?
Yes.
Yes.
Okay.
Are you sure, Greg?
And we have our steps that we need to do to solve these division problems. We're taking the reciprocal of the divisor and multiplying the rational expression together. And if we encounter a complex fraction, we're just going to rewrite that as a division problem of two rational expressions. You know what? I should put like or Jeremy's method, like right here. But I like that. But